Question 1. A developer is building a new application with an unpredictable and highly variable workload, and they want to ensure the database can scale instantly to meet demand without cold start issues. Which Aurora Serverless version is best suited for this requirement? Option A. Aurora Serverless v1, as it scales to 0 when idle. Option B. Aurora Serverless v2, due to its instant scaling capabilities and minimal compute footprint. Option C. Aurora Serverless v1, because it offers the data API for simplified integration. Option D. Aurora Serverless v2, but only if integrated with RDS proxy for connection pooling. The correct answer is Aurora Serverless v2, due to its instant scaling capabilities and minimal compute footprint. Here's the explanation. Aurora Serverless v2 was specifically designed to address the cold start issues of v1, offering instant scaling from fractions of an ACU to hundreds of ACUs within milliseconds. This makes it ideal for highly variable and unpredictable workloads requiring immediate responsiveness. While v1 scales to 0, it has cold start latency. Question 2. Which statement accurately describes how billing works for Aurora Serverless? Option A. You pay for provisioned database instances regardless of usage, similar to Aurora Provision. Option B. You pay only for the storage and I/O operations, with compute capacity being free. Option C. You are billed for the exact database capacity consumed, measured in Aurora Capacity Units, ACUs, along with storage and I/O. Option D. Billing is based on a fixed monthly subscription fee, irrespective of actual demand. The correct answer is you are billed for the exact database capacity consumed, measured in Aurora Capacity Units, ACUs, along with storage and I/O. Here's the explanation. Aurora Serverless employs a pay-per-second billing model for compute capacity, measured in Aurora Capacity Units, ACUs. You also pay for storage and I/O operations. This ensures cost-effectiveness for intermittent and variable workloads, as you only pay for what you consume. Question 3. Which of the following is not a primary benefit or characteristic of Amazon Aurora Serverless? Option A. Automatic scaling of compute capacity based on workload demand. Option B. Elimination of the need to provision, scale, and manage database servers. Option C. Guaranteed consistent high performance for consistently heavy, predictable workloads at a lower cost than provisioned Aurora. Option D. Cost effectiveness for intermittent, unpredictable, or highly variable workloads. The correct answer is guaranteed consistent high performance for consistently heavy, predictable workloads at a lower cost than provisioned Aurora. Here's the explanation. Aurora Serverless is ideal for intermittent, unpredictable, or highly variable workloads. For consistently high, predictable workloads, a provisioned Aurora instance might be more cost-effective and provide more consistent performance guarantees, as serverless's auto-scaling mechanisms introduce some overhead and are optimized for variability, not absolute peak sustained performance at the lowest cost compared to a perfectly sized provisioned instance. Question 4. Which statement best describes Amazon DynamoDB's fundamental characteristics? Option A. A fully managed relational database service designed for complex SQL queries and joins. Option B. A self-managed NoSQL key value and document database requiring manual scaling and replication. Option C. A fully managed, serverless NoSQL database service delivering single-digit millisecond performance at any scale. Option D. An in-memory cache service for accelerating read-heavy relational database workloads. The correct answer is, quote, a fully managed, serverless NoSQL database service delivering single-digit millisecond performance at any scale. Here's the explanation. Amazon DynamoDB is a fully managed, serverless NoSQL database service. It is a key value and document database designed to deliver single-digit millisecond performance at any scale, automatically handling data partitioning, replication, and throughput management. Question 5. A DynamoDB table is configured with a partition key and a sort key. An application frequently needs to query items based on an attribute that is neither the partition key nor the sort key, and requires the ability to query across the entire table. Which type of index should be used for this access pattern? Option A, Local Secondary Index, LSI. Option B, Global Secondary Index, GSI. Option C, Simple Primary Key. Option D, Time to Live, TTL. The correct answer is Global Secondary Index, GSI. Question 6. For a critical application, a developer needs to ensure that read operations always return the most up-to-date data, even if it means slightly higher latency and cost. Which read consistency model should be chosen for DynamoDB? Option A, Eventually Consistent Reads. Option B, Strongly Consistent Reads. Option C, Transactional Reads. Option D, Cached Reads via DAX. The correct answer is Strongly Consistent Reads. Here's the explanation. Strongly consistent reads ensure that a read operation returns the most up-to-date data, reflecting all successful writes that occurred before the read. While this consumes twice the read capacity units, RCUs, and has higher latency than eventually consistent reads, it guarantees data freshness. Thanks for watching. Please subscribe to my channel.